Hello dears. In today's class, we are going to discuss about the combination of resistors. As you know, we can connect resistors in two methods. That is, first one is series connection and the second one is parallel connection. And we will look into detail. In combination of resistors, that is in series connection, you can see here in this picture three resistors are connected in series, which means the end of the resistor 1, which means the first end of the resistor 1 is connected to the negative terminal of the battery, and the second end of this first resistor is connected to the one end of the resistor 2, and again this resistor 2 is connected to one end of the resistor 3, and the other end of this resistor is connected to the positive terminal of the battery. Here this terminals of the battery you can exchange, like R1 can connect it to positive and the end of R3 can connect to negative. That's up to you. And here potential difference is applied across the all resistors, which means here R1 is having potential difference V1, R2 is potential difference V2, and R3 here potential difference is V3, which means here V3, V2 and V1, the potential differences are equally divided, which means it according to the value of the resistance, and if the resistance is different, the amount of current and the potential difference will depend on the value of that resistance. Here we can take it as V1, V2, V3 across the resistance R1, R2, R3, and the current will flow from left to right because the electrons flow from negative to positive and the direction of the current is opposite to the flow of electrons. Therefore, you can see the direction of current is like this here, I, and the I is distributed through this total resistance, and here V1, V2 and V3. And we can write this potential difference V is V1 plus V2 plus V3. But in series connection, we know the current flow is same. Therefore, V is equal to I into R. That is, V1 means I into R1 plus V2 is I into R2 and V3 is I into R3. And here taking I outside, I into R1 plus R2 plus R3, and here I is common in left hand side and right hand side, so we can cancel it out, and the value of this resistance is R is equal to R1 plus R2 plus R3. That is the total value of the resistance, which means when we connect n number of resistors in series, the total amount or the equivalent resistance offered by the circuit is, that is, R equivalent is equal to R1 plus R2 plus etc. up to Rn. And in the second figure, you can see resistors are connected in parallel. While connecting parallel, you can see this R1, R2, R3. One end of these three resistors are connected to the positive end of this battery, and the other end of R1, R2, R3 is connected to the negative end of the battery, which means potential difference is applied across these combinations of these three resistors. Whatever it is, how many, if n number of resistors are there, the potential difference is applied across all the ends of these resistors. And you can see the potential difference is same, and here the current will flow in different paths. Here you can see a junction, these two ends there is a junction, and current will flow like I1, I2, I3, which means if we connect this resistors in parallel, here what is happening, you can see three resistors are connected in parallel, and here the current you can see here one junction is there, so current will split I1, I2, I3. It will depend on this value of R1, R2 and R3. Here again it will flow like I, which means I1, I2, I3 will join and will flow as I. And when we consider the combination, here current is different, therefore we can take the overall sum of this current, that is I is equal to I1 plus I2 plus I3. As per Ohm's law, we know I is equal to V by R, and we can write this I is V by R, and that is equal to I1. I1 means V divided by R1. Since this potential difference across the combination of the resistors are same, therefore V is common everywhere. And in I2 you can see V divided by R2, and plus I3 means V divided by R3. So when we write this equation, we can cancel this V in the both in left hand side and right hand side. Therefore, cancelling this V, we can write 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is 1 by R equivalent. And if we have n number of resistors, the total resistance 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus etc. up to 1 by Rn. So that is the combination of resistors in series and parallel. And I hope everyone understood the class. Keep on watching my videos, and please subscribe my channel. In the next episode or in the next class, we will discuss another derivation. Thank you.